compound interest compounding periods. Sometimes two interest rates may look the same, but in fact they're not equal to each other. One of the reasons might be that the compounding periods might be different. A compounding period is how many times the interest is calculated per year. The common compounding periods are annually, quarterly, monthly, fortnightly, weekly, and daily. This table will be handy for the problems that we'll be doing. Annually means once per year, quarterly means 4 times, monthly 12, fortnightly 26, weekly 52, and daily 365. To do the problems outlined in this video, I'm going to be following these steps. Number 1, calculate the interest rate per period, which is our lowercase r. Calculate the growth factor, which is our capital R. Calculate n, which is the number of periods. We need to do all of this so that we're nice and careful and get the correct answer. All the questions we're going to do in this video are going to be based on this particular example. $50 is invested for 2 years at 6% compounding annually. So our R is 6% per annum, our N is 2. Our capital R is 1 plus R over 100, which is 1 plus 6 over 100, which is 1.06. When we use the compound interest formula and substitute in, we get 50 times 1.06 to the power of 2, which gives us $56.18. To work out the interest, we take 50 away from the $56.18. That gives us $6.18. We're going to do example 1 again, but this time it's going to be quarterly. Just keep in mind that there are 4 quarters in a year. Our R becomes 6 divided by 4. So our interest rate is 1.5% per quarter. Our N is the number of quarters. Now, if there's 4 quarters in 1 year, over 2 years, there's going to be a total of 8 quarters. Our R is 1 plus R over 100. We substitute in that 1.5, which gives us 1.015. When we use the compound interest formula, we get 50 times 1.015 to the power of 8. That gives us $56.32. The interest is going to be $56.32. Take the $50 and we end up with $6.32. We're going to do example 1 again, but this time it's going to be monthly. To work out our R, it's going to be divided by 12 because there's 12 months in a year, which gives us 0.5% per month. Our N is going to be 2 times 12. The reason is over 1 year there are 12 months, over 2 years there's going to be 2 lots of 12 or 24 months. Our capital R is equal to 1.005. When we use the compound interest formula, it is 50 times 1.005 to the power of 24, which gives us $56.36. The amount of interest works out to be $6.36. We're going to do this problem one more time, but compounding weekly. Our R is 6 divided by 52 because there's 52 weeks in a year. That gives us 0.12% per week. Our N is equal to 2 times 52. Because there is 52 weeks in 1 year, over 2 years there's going to be 2 lots of 52, which gives us 104 weeks. Our capital R works out to be 1.0012. Our compound interest formula gives us 50 times 1.0012 to the power of 104, which gives us $56.37. Our interest works out to be $56.37 minus 50, that gives us $6.37. But wait a minute, when you put 50 times 1.0012 to the power of 104, you get $56.64, not $56.37. What's going on here? My calculations were correct, it's just that I didn't show all my decimal places. For R is equal to 0.12, I had 0.1154 plus some other decimal places in my calculator. And it was the same with capital R, and also the calculation at the end. Here is a situation where rounding to even 4 decimal places is not going to get you the right answer. You need to actually have far more decimal places like that in your calculator. The best way to approach this on the calculator is to go 6 divided by 52. This is our lowercase r. Works out to be this number here. When it comes to working out our uppercase r, 1 plus, we're going to insert in that previous answer. So by using that answer button, it inserts all those decimal places. So that means when you get your r value, it is correct to all those decimal places. When it comes to the compound interest formula, again, you're going to resubstitute in that value. So 50 times the previous answer to the power of 104 gives you the answer of $56.37. Now if you do it this way, you can be confident that your answer at the end is correct to those many decimal places. If you don't have a fraction key on your calculator or you don't know how to use it, you can use division. So 6 divided by 52 gives you that answer. And then again, we're going to use the answer button. 1 plus answer divided by 100 gives us this answer. And then we're going to use that again in the compound interest formula. Now, in there, you'll notice after the answer, I've got this up arrow, and that means to the power of. A lot of calculators have that little up arrow. And when you use that, you end up with $56.37. Let's summarize questions 1 to 4 in a table. So for our first question, which was annually, the R was 6, the N was 2, the capital R was 1.06, and the total amount was $56.18. When we went to quarterly, our lowercase r we divided by 4, N we multiplied by 4, and we got a capital R of 1.015, and we got $56.32. When it came to monthly, we divided the lowercase r by 12, we multiplied n by 12, and our capital R ended up being 1.005, and we got an answer of $56.36. For weekly, our lowercase r divided by 52, our n we multiplied by 52, our capital R was 1.0012, and the total amount was $56.37. There are some things to notice. The same number you divide to get r is used to multiply to get n. Now that was the case for every example in this video. However, just a word of caution, it will not always be the case. There is a pattern to go from lowercase r to capital R without a calculator, and some of you will be able to figure this out for yourselves. However, only attempt this if you have a good understanding of place value. You might notice that the more frequent we calculate the interest, the higher the total amount ends up being. However, it converges on a particular value. For instance, if we worked out daily or even hourly interest, we'd still get $56.37 to 2 decimal places. So let's recap. Interest is commonly calculated annually, monthly, fortnightly, weekly, and daily, but other compounding periods exist. The answers will differ slightly depending on which one that you use. For accurate calculation, use the answer button on your calculator. Thanks for watching. Please subscribe and hit the like button. Please leave a review and a comment. I'm not a financial advisor. I'm an experienced mathematics teacher with a passion for teaching financial literacy. Please read the disclaimer.